Hello all, welcome to this video where we're going to look at tokenization and stopwords technique under NLP. So in previous videos we saw what NLP was and what was the general flow of NLP techniques. So today we will be looking at tokenization methods and stopword removal methods in NLP. So these two methods are basically kind of the first steps which we have to take whenever we are applying some NLP techniques on any kind of text. So for this, let us first take a sample text with us on which we are going to perform our tasks. So this is a text which I have taken out from the internet today. This was a news article which I came across. So I have taken the first paragraph of it. You can choose any text of your liking and perform the tasks over there. So what we're going to do is we're going to first import the tokenized method from the NLTK library. This is how you can import it. Once you've imported it, the first thing that we're going to do is we are going to tokenize the text, the data that we have on a sentence level. So when I say tokenize, as the name suggests, we are going to break the text data that we have into sentences. We might have some 10,000 lines or 1 lakh lines of data. The first thing that we want to do is we want to break the entire text into sentences so that we can access each and every sentence separately for further analysis. So the way to do is to use the sent_tokenize method under nltk.tokenize. So here it is. If you run this code, what you will find is this particular method will break the text, the data that you have, into sentences, right? So if you observe it, we had this data, the first statement started from here and ended here. This was the first full stop that we encountered. So the method sent_tokenize would return us a list of sentences separated at full stops. So when you see, when we have the output of this function has been given into this variable called tokenized_text, and when you check the length of this variable, you see there are now 4 elements inside it. These 4 elements are the 4 sentences from which this entire text was made earlier. Similarly, we can further tokenize the entire textual data into words. So how do we do that? Similarly, we can use a function called word_tokenize, which would tokenize the entire data on a word level. So if we look into it keenly, we will find that the text, when passed through this function and stored in this variable, gave us this output. If you want to study it, see, the length of this variable is 113 elements, which means now there are 113 words inside total of this text. So this is what tokenization is. Now once you have tokenized the data, you can again apply the frequency distribution function which we saw in the earlier videos. This is one kind of analysis which is always performed on a textual data. So what we are going to do is we are going to again use the same function which we used in the last function called frequency distribution function. So there are 2 ways of doing it. We can apply this frequency distribution function on the sentence level tokenized data, but it will not be of good use because there were only just 4 sentences inside that output. So what we are going to do is we are going to implement this frequency distribution function on the word level tokenized output. So which was this tokenized text word was the variable where our word level tokenization was stored. So when we use this function, we see we have 74 samples out of 113. So 113 was the output here. We saw that total number of words when tokenized, the entire text was when tokenized gave us the output of 113 words. So out of 113 words there are 74 samples, that is there are 74 unique words in this. Now when we find the top 5 most common most common words used, we see that again words like the, of, in are again in the top list. So we observed this particular thing in the last video also. Whenever we run this frequency distribution function and find the most common words, we always get words like the, of, and, in, a. So these words again are not very helpful when you want to draw inferences out of a text, when you want to do some analysis, you want to conclude something. They will not add too much of the analytical value. But so what do we do now? So this is where the concept of stop words come in. Stop words are those words which are basically of very little use to us when we are analyzing a textual data. So these are generally considered as noise when it comes to NLP. So what we do is, first we remove these words from the entire text, that is, we remove the stop words from the entire text, and then we are left with the data which might be useful for us for further analysis. So how do we do it? So as we saw in the earlier videos, there are various corpus available inside the NLTK library, one of which is stop words. So stop word is a predefined list of words which can be removed from any textual data before NLP analysis. So how do we do it? To access it, you need to first import it the same way we import other corpus. Then we need, because we are analyzing the data in English language, so we need to import stop words for English. So this is how you do it. So there are a total of 179 stop words inside this list. If you check the length of the stop word list, you will find this. We now store these stop words into a variable, and we run a for loop here to remove the stop words from the original text. So how do we do that? We run a for loop where we use the word level tokenized data, because we are going to compare word with a word. So we need to be having the tokenized level at word level, right? We cannot compare words with sentences or word with the entire text. We need to be able to compare word with word. So therefore we are going to use the variable we have, where we have stored word level tokenized of the original data. So once we run this for loop, what we do is we have initiated a empty list over here in which we are going to store the filtered text as in we are going to remove the stop words from the entire text, and whatever is remaining will be stored into this initiated list over here. So once we run this for loop, we find that the total length of the newly formed list is just 69, and how many words did we have in the original text? 113. This means the stop words have been removed, and now we are just left with 69 words. So if we try to print it, what we get is there are no stop words remaining now, although still we can find some words like comma here which might not be of much use, but we'll get to it later on, how we deal with such things, and if are actually do we want to remove full stops and commas or not. So all these things will be taken care of later, but right now what we have done is we have removed a generalized list of stop words from our original text. So this is how you can remove stop words which are generally considered as noise for any NLP task. So in this video, what we have learned: first, we saw what was tokenization. We tokenized the entire text on two levels, that is, one was sentence level and second was the word level. After tokenizing, we realized that there are many words inside that text which are of no use to us, which can be considered as noise. So we removed those words by the term stop words, and we were left with a list of words which were actually useful, which could be useful for us for further analysis. So tokenization and stop words is a very basic concept which we covered in today's video. In the next video, we are going to be looking at lemmatization and stemming. So I hope you liked this video, enjoyed it. Please like and subscribe, and meet you in the next video. Thanks a lot.